Class, I'm doing what I'm calling a living solutions manual. So you can use this in two ways. You could either do all the problems yourself and come back and watch the solutions, or you can try a problem, watch a solution, try a problem, watch a solution. But the main thing is you need to try the problems. And I guess the third way you could do it is watch all the solutions, stop watching it and try all the problems yourself again after seeing the solutions. So here we go. I'm going to do, in this one, I'm going to do numbers 1 through 8. So this one's just going to be problems 1 through 8, which takes quite a bit of time. So let's get started. Number 1. It says find the measure of the largest angle of a triangle if the measures of its interior angles are in the ratio of 3, 5 to 7. I may not do this quite like the book taught it, but I'm just going to take a stab at this. I can't draw the triangles in the right ratio, so I'm just going to draw the standard triangle. It looks isosceles, but just pretend like it's not. So the sides of this triangle are 3, 5, and 7. So let's just put the sides on here. They're to the ratio of 3, 5 to 7. So 3 to 5 to 7 is their ratio. So what you're going to do when you put your sides on here, the ratios are going to be 3x, you just say 3x, 5x, 7x. And so that means the angles are going to be in the same proportion. So we're going to make those 7x, 5x, and 3x. All right, we just needed the sides to be able to get the angle proportion. See how they're going to go with the sides? They're going to be in the same proportion as the sides. The longest side is opposite the biggest angle. So once you set that up, then you're just going to add all the angles up. 3x plus 5x plus 7x equals 180 degrees. You add that up, you get 15x. I'm going to go as fast as I can, equals 180, and you're going to get x equals 12. They want to know what the largest angle is, so that would be the one with the 7x. So you would say 7 times 12 equals 84 degrees. That's the largest angle. All right, let's do another one. We're just going to move really fast here. This time we actually have an isosceles triangle, so my picture is actually going to make sense this time, my triangle. There we go. And we're going to, it tells you that the measure of the vertex angle, find the measure of the vertex angle of an isosceles triangle if the measures of its vertex angle and the base angle has a ratio of 4 to 3. Okay, these are the equal sides. These are the base angles. Base angles in isosceles triangles are always the same. This one up here is called the vertex angle. And the ratio between the vertex angle and the base angles is 4 to 3. So the easiest way to do it is just put your vertex angle as 4x. Your base angles are each 3x, and then set them equal to 180. So you'd say 4x plus 3x plus 3x equals 180. You get 10x equals 180, and x equals, whoops, my thing went away again. I'm having a little trouble with the writing down at the bottom, so I'm going to have to keep scrolling up. So we're going to get x equals, this should have been 10x, equals 18. What are they asking for? Don't forget what they're asking for. They said find the measure of the vertex angle. The vertex angle is 4 times x, so you take 4 times 18, which is 72 degrees. Next, I'll just keep scrolling. Each time it goes back up, unfortunately. All right, 3. This time we have ourselves a parallelogram. My little computer thing doesn't do parallelograms, so I have to do my own. Okay, this one says the measure of consecutive pairs of angles of a parallelogram have the ratio of 5 to 7. So consecutive means here, either here and here, or down any two consecutive ones. Okay, so the ratio is 5 to 7, so we're going to make this one be 5x and this one be 7x. Like that. And you can see the opposite angles are going to be congruent in a parallelogram. So any two consecutive are going to be 5 and 7. And we know that consecutive angles in a parallelogram add up to 180 degrees. So we get 12x equals 180, and we get x equals 15 degrees. They want to know, whoops, it's not going to be degrees, it's just x equals 15. That's not what they're asking for. They're asking for the measure of each angle. So one is going to be 5 times 15, which is going to be 75 degrees. And the other one's going to be 7 times 15, which is going to be 105 degrees. And they add up to 180, so we're pretty sure we have the right answer there. Okay, number 4, we're changing up a little bit. These ones are proportions. This should be really easy. This is real simple algebra here. So hopefully this is an easy part. Let's just scroll on up. All right, so 4, solve for x. So a, look how easy these are. 2 over 6 equals 8 over x. This is called the means times the extremes. So we're going to multiply this way. The product of the extremes equals the product of the means. So we're going to get 2x equals 48. X, you should like these, equals 24. Let's see, did I do this one somewhere? Oh yeah, okay. So these are really easy. We'll just whip right through these. Okay, B is 2 over x equals x over 50. These two numbers right here are called the means. And the two here and here are called the extremes. Just for future reference in the next kind of problem. Okay, so we're going to cross multiply. We're going to take 2 times 50 and get 100. X times x is x squared. X has to be 10. And that's that. So let's hit another one. They get a little bit more complicated, so that's why I'm going to keep going here. 2x minus 5 over 3 equals 9 over 4. Cross multiply. 4 times 2x minus 5 equals 27. This one's not so nice. 8x minus 20 equals 27. Add 20 to both sides. You get x equals 47. It's not divisible by 8, so you'd say x equals 47 divided by 8. All right, next one. 4 over x plus 3 equals 1 over x minus 3. Cross multiply. 4 times x minus 3 equals x plus 3. Distribute. 4x minus 12 equals x plus 3. 3x equals 15. And x equals 5. That was pretty fun. And our final one. And I'm out of room. Hold on, new board necessary here. All right, this is E. 3 over x. These you should have been able to do on your own anyway. Over 7. So you get 21. Cross multiply. X squared minus 4x. Quadratic, because it's to the second degree, so it has to be set equal to 0. 4x minus x squared minus 4x minus 21. Quadratics have to be factored. So you get x, and I'm guessing 7 and 3, negative, positive. Because the outer is positive 3x, the inner is negative 7x. Add those together and you get negative 4x. So set those each equal to 0. You get x equals 7 and x equals negative 3. 2 answers for that one. And that's it. Okay, next kind of problem. Let's just go down again. This kind says find the mean proportion between the pair of extremes. So I just showed you what the extremes were. Okay, theorem 10.1 says the product of the means equals the product of the extremes. If the second and third terms of a proportion are the same, then either term is referred to as the mean proportion or geometric mean between the first and fourth term. Okay, let me just write that out a little bit. So we would have A over M equals M over D. This is called a mean proportion. Mean proportion. And the reason it's called a mean proportion is because these two guys are the same. So you could also say M is to M as M is to D. So let's just try one of these, all these problems, I guess. I'm not sure if I'm going to do them all. I think I'm going to do the first couple here. So this one says find the mean proportion between the pair of extremes. Remember I told you that these are the means and these guys out here are called the extremes. They're on the extreme ends, right? See, they're on the ends of a proportion. So they're going to give you the first one. A is 4 and 16. They're giving you the extremes. You have to find the means. So they said to use the mean proportion. So that means you're going to do two fractions, set them equal to each other. These guys here, these are the extremes. So you put them in their extreme spots. And then you just put an x to represent the means. You just do a little cross multiplication, so you get x squared equals 64. Square root of 64 is 8. And we're only going to do the positive square root for those. Let's try the next one. B is 3e and 12e cubed are the extremes. So you set them up like this, 3e, 12e cubed, and you put your x's for the means. You cross multiply and you're going to get 36 e to the 4th equals x squared. Take the square root of both sides and you're going to say x equals 6e squared. And I'm having trouble with the bottom of my screen. Okay, scroll down. It's a slow scrolling process here. All right, I think you can do the rest by yourselves on those. Just put those two numbers like 1/2 and 1/8, put them in extreme spot, put x's for the mean spot. Okay, 6. In each part, determine whether the ratios are in proportion. All right, let's look at the first one as I explain it. So you get 1/2 equals 9/18. You have to explain if their ratios are in proportion. The way you tell, you could just reduce the fraction, see if they're the same thing, but let's do the way that they want you to learn it. To tell whether the ratios are in proportion, the means should equal the extremes. So if the means, product of the means, equals product, that's times, of extremes, then, therefore, that means therefore, proportional. So we're just going to cross multiply. We get 18 equals 18. So they are, those pairs of ratio are in proportion. So you can see this one's really easy. Again, I don't think I'm going to do all of these. Let's do B. You get 12 over 20 equals 3 over 5. Cross multiply, get 60 equals 60. Yes, and let's just do C. 4 over 9 equals 12 over 36. I mean, this is the way you check them, but let me just show you something. 144 equals 108. Whoops, 108, and that doesn't work. So it's no. I mean, if you can see, if you take this times if you take this times a 4 and this times a 4, you get it. So you know that they're proportional. But you can also, for future problems where you have more variables, you have to do the means times the extremes. Should be equal. Okay, we are moving fast here. Number 7. Okay, here's where it starts getting a little trickier. Number 7. We'll fit it one more on here. Let's draw a triangle. It says in BAG, LM intersects side AB at L and side AG at M so that LM is parallel to BG. Write at least 3 true proportions. Do not generate equivalent proportions by inverting the numerator and denominator of each ratio. Okay, you may have no idea what I just said, so let's just set this up. So we need to set up a triangle BAG. So I'm just going to use my little triangle drawer here because it works for isosceles triangles as well. I'm going to draw myself a segment parallel to the base because that's the main part about it. I'm going to label my triangle BAG. And they want us to come up with equivalent proportions. So here we go. This is what the theorem says. It says a line parallel to one side of a triangle divides the sides proportionally. So what does it mean that it divides the sides proportionally? Well, there's three cases. So you have like A, like a part on the top, a B, and a C, and a D. So let's just put those there. If it's parallel, what it means is A to B is going to equal C to D. That's the first case. Okay, case one. So top to bottom equals top to bottom. That's the first case. Okay, the second case is top to whole. So we're going to say little a over the whole, which would be big A, is proportional to the top of the right side to the big right side, AG. That's the second relationship that you can get. So it's top to bottom equals top to bottom, top to big side equals top to big side, and then our third case is bottom to big side equals bottom to big side on the right. And that's about all there is to that. So there's three different ratios that you can get. Little to little on both sides, top little to big side on the left side equals top little to big side on the right side, and then the same with the bottoms. All right, now put that into practice here on the next problems. All right, number 8. This is the last one we're going to do for this one, and then I'll do another video with the last ones. So this should get you through Wednesday, and then there'll be another one for Thursday. Okay, let's draw this triangle again using my triangle drawing tool because it's so much easier. And let's draw a line across here, parallel to that. Okay, and we will label it like the book says, ATP, BC. And they're going to tell us that we have to determine whether TP is indeed parallel to BC. So the rule says a line parallel to one side of a triangle divides the sides proportionally. The reverse of that is if the sides are proportional in a triangle with this line, then the lines are parallel. So we're going to see if they're proportional. Let's just try the first one to see if it makes sense here to you. So AT equals 5, TB equals 15. We'll go slow at first, then I'll speed up. AP equals 8, PC equals 24. I'm going to draw these in, and maybe then I'll erase them. So AT is 5, TB is 15, AP is 8, PC is 24. So if you remember what we did in the last problem, there's relationships. So we're going to check out to see if the we can do proportions, and if the proportions are equal, then we know that these two sides are parallel. So here we go. So since we have all the little parts, we can put the little parts proportional and see if it works out. So we're going to say 5 over 15. Remember, little over little equals little over little. Now, if that's proportional, then we know that these two sides are parallel. So we can, well, looks like the best way to do this is to cross multiply. So we get 5 times 24 is 120. 8 times 15 is 120. And yes, they are indeed, the sides are going to be parallel. So we say yes, sirree. Okay, let's just see if we can squeeze another one on here with this diagram. Actually, I'm just going to draw a new diagram for each one. It's just going to be faster with my broken computer part today. Okay, here we go. Let's get this one in. Okay, B, it says TB. I guess I need letters because I don't have them memorized. A, T, P, B, C. All right, and let's just fill them in as we go. TB is 9. That's 9. AB is 18. Well, that's this one out here, right? So I'm going to put that one's 18. Let's see. AP is 6. And AC is 15. Well, we learned the relationship. Okay, we have a slate problem here. AP is 6, PC. All right, there's two different ways we can do it. We can either fill it in and say, well, this one must be 9, and this one must be 10. We can do it that way. I'm just looking to see what I did on mine. I don't think I did part B. Okay, so since they're giving that, let me just check it again. TB is 9, AB is 18, so this one has to be 9 because these two have to add up to 18. AP is 6, the big one is PC is 6. Actually, I didn't do that right. I don't know where I got that 16. I thought something looked funny there. All right. All right, so we have some information. We could do little to big, top to bottom equals top to bottom. Or we could do top to big. Let's just do it that way for, no, I don't know. You can do it either way. But since we did it the same way last time, let's do bottom to big. So 9 to 18 equals, this would be 12, right? 6 to 12. And then we'll cross multiply. So we get 108 equals 108. So these indeed are parallel. So we can say they're parallel. So the best way to do these, in my opinion, is to draw the triangle every time and fill it in. Because the information, they don't always give you enough information or in the right place. So let's do C and maybe one more after that. So let's get the letters A, T, P. I know you're all busy people with lots of important subjects to do, so I don't want to spend too much time on this. This will save time in class though. Let's just do this last one. Actually, we have to do E too because it's really hard. Okay, so AT is 4. Let's fill in all the parts. They give us AB is 12. So it's telling us that this one is 12, so we'll know that this one is 8, right? Then they're going to give us AP is 6, and AC is 15. There's where that 15 came from. So we know that this one's going to be 9. So let's do, remember there's all different ways we could do this. We could do top to bottom equals top to bottom. Or we could do top to whole equals top to whole. Or we could do bottom to whole equals bottom to whole. Every one of these relationships should work out if they're going to be parallel, but maybe they're not. So let's just cross multiply one of these. So we're going to get 36 equals 48. And right away we would say, no way. And if we did this one, we were going to get 60 equals 72. So none of these should work. But if it were true that these were parallel, see these are not parallel, then all of them would work. So do you see the relationships? Top to big, bottom to big has to equal bottom to big. Top to bottom equals top to bottom. Those all would be true if the lines were parallel. And we're going to look at the last one because it's kind of odd. It's oddly difficult. So let's look at E. You should be able to do D on your own. Here we go. Let's draw our triangle. Let's put our line in there and put our letters on the guy. Here we go. Letters. So we have ATP and we have BC. And this is kind of wacky. It says AT equals 1/3 of AB. And then we're going to get PC equals 2AP. So what I did was I said AT over here is 1/3 of AB. So I made this one be 1/3 of 1, called this 1. And so this one would be 2/3, right? And PC is 2 AP. So I made this one 1, and this is 2 times it. So I kind of made up my own numbers based on the ratios, and then I set them equal. I did top to bottom equals top to bottom, and when I cross multiplied, we got 2/3 equals 2/3. Remember, you could have also done it, you could have done little top to big equals top to, of course this would have been 3, like that, and when you cross multiply 3 times 1/3, you'd say 1 equals 1. It should work out anyway. Top to big equals top to big. Top to bottom equals top to bottom. Bottom to big equals bottom to big. See, we could have done the last one. I know this is redundant. 2/3 bottom to big equals bottom, which is 2, to big. And when you cross multiply, you would have had 2 equals 2. All right, that's it. We'll quit there, and I'll do another video for the rest later and send it to you. So hopefully we won't have a lot of questions in class, but if you do, we'll have time to answer them. I am trying to log out of here. My computer's giving me a hard time.